Right guys, hope all of us are doing fine. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at different arrangements of resistors in a circuit. And basically, I'm going to look at two different sets of arrangement of course, resistors in what we refer to as a series arrangement and a parallel arrangement. So in this case, we're going to create a contrast between the two and see some of the applicable laws, especially the Kirchhoff applicable laws, which are going to assist us in trying to find various resistance. Now, in this particular case, we're going to see that the two specific sets have got a source of electromotive force, and therefore, when these particular switches are going to be closed, there's going to be a flow of current, and therefore we can find the various amount of particularly resistance which is going to be offered from these two specific arrangements, and that's going to be particularly application of what we have referred to as Kirchhoff's law. In this case, the relationship we are going to identify from this specific set, which is the first one, is that the potential difference which is going to flow across these three resistors are going to sum up to the amount of V. Now we can have this relationship given in terms of V equivalent to V1 flowing through R1 plus V2 flowing through R2 plus V3, given in that specific order. So therefore, we're going to use that relationship in trying to find the amount of resistance being offered, or how we can identify the resistance being offered using this specific series of the series arrangement. And therefore, this is equivalent to V1 is equivalent to the current flowing through this. So the current flowing through this specific amount of resistance is going to be the same. Therefore, we are going to indicate it using I. So IR is equivalent to V1. So we are going to have I, which is a constant, R2 plus R3 given as such is equivalent to V. So we can have this relationship of V still expressed in terms of this common factor of I into R1 plus R2 plus R3 given as such. And then we're going to have the ratio of V over divided by this common factor equivalent to R1 plus R2 plus R3. So from our previous discussion on the concept of Ohm's law, I mentioned that basically the ratio between V over I is going to give us resistance. And therefore, we can define this resistance for this series in terms of R1 plus R2 plus R3. So the total resistance which is going to be realized from this series, of course, arrangement of resistors can be given in terms of this specific formula, whereby we're going to find R equivalent to R1 plus R2 plus R3 given as such. So suppose we look at this specific aspect of resistors in parallel. We're going to look as well at the potential difference across each resistor, which is going to be given in terms of course, V. But we're going to consider the relationship between current and resistance and try to see what are some of course, just as we have done in this specific case, and try to see what are some of current and voltage, and try to see what are some of the, of course, realization we are going to achieve from that. In this case, we're going to see that the current that's going to flow in this specific, of course, arrangement is the sum of I1 plus I2 plus I3. And that is going to be the currents are flowing through those specific resistors. Now, in this case, we are going to have R1 given in terms of, this is going to be, basically that's going to be the ratio between what we have refined from this specific case, which is going to be V over R. So we're going to have R1 given in terms of V over R1, and this is going to be I1, just give it correctly as such. So this is going to be I1, which is going to be this specific current given in terms of VI1. So in this case, this is going to be flowing in this specific resistor. So we're going to have I2 given in terms of V over R2, and of course I3 given in terms of V over R3 in that specific order. So we can simply do an evaluation of the current which is going to flow through the entire circuit given using this specific illustration. by doing a substitution of V over R1 plus V over R2 plus V over R3. And this is going to be shown still using V into 1 over R1 plus 1 over R2 plus 1 over R3. And of course, the ratio between I over V is equivalent to 1 over R1 plus 1 over R2 plus 1 over R3. But if we look at the relationship for I over V from this specific case, perhaps I can just have this one. If we have I equivalent to V over R, then we can have I over V equivalent to 1 over R. So in this case, we can have this one as substituted for 1 over R equivalent to this specific sum over 1 over R1, 1 over R2, 1 over R3, given in that specific order. Now, in this case, for the arrangement of our resistors in, of course, a parallel form, we're going to see we can find, suppose we have two resistors, we can find this one by finding the product of a sum, and that is going to give us, of course, R effective. So suppose we had perhaps two resistors. In this case, I can just do that one for illustration purposes. And this is going to be an arrangement for the parallel arrangement. So that suppose we had two resistors for R1 and 2. This basically can be found using the product of the two over the sum, basically indicating that it's R1, R2 over R1 plus R2 given as such respectively. And that's how we're going to use this specific formula in trying to find the arrangement of resistors either in series or parallel from various evaluation we're going to come across. So kindly check our description boxes for various links of other videos, and also subscribe and engage us in the comment section for other related content. So that is it for now, guys. Bye, God bless you. Catch us in our next video.